I'm Miss Stamey, and we are outside my house today. We're going to be talking about functions today. I've got my helpers here. This is Owen, he's 8, and this is Izzy. She is almost 5. She'll be 5 next month. And they're going to help me out with some data collection here today. So I want you guys to go ahead and go down all the way to that first tape mark that we marked off. What we're doing today is we have 50 yards marked off here on the road in front of my house, and we're going to have Owen and Izzy walk off or run off that distance, hopefully at a steady pace, all the way from the 0 yard to the 50 yard. I've got tape marks at each 10 yards, so each time they cross one of those marks, they're going to let me know in some way, and I'm going to write down the number of seconds. I'm going to have a stopwatch over there, and I'm going to record the number of seconds it took them to get to each mark. And so that's going to give us a set of data points that we're going to work with in a few minutes to talk about functions. Okay, so I think we're ready to get started. I will go over to the stopwatch and get them started. Okay, Owen, you're going to go first, right? Okay, when I say go, I want you to go, and then you've got to keep a steady pace, and I want you to somehow let me know every time you cross one of those yellow lines. Got it? Give me a thumbs up. Okay, remember, Izzy, you wait till your turn. It's just Owen's turn this time. Okay, Owen, I am ready. Go. Here. 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 Great, Owen. Okay, Izzy, are you ready? Give me a thumbs up. 2 thumbs up. All right. Okay, when I say go, you go. And tell me every time you cross one of the yellow lines, okay? Go. Here. 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 Great, Izzy, thank you. Have fun. All right, see you later, girly. Okay, what we have here, guys, I have on the board, I have Owen's distance, 10 yards, 20 yards, 30 yards, 40 yards, 50 yards, and then his time in seconds, 4 seconds, 6 seconds, 8 seconds, 11 seconds, and 13 seconds. That's Owen's time. Izzy's time is over here. At 10 yards, she was at 5 seconds, 20 yards, 8, 30 yards, 12, 40 yards, 15, and 50 yards, she was at 19 seconds. So what we have here are basically sets of ordered pairs. You see me? I have order pairs listed below each one, so let's fill those in. So at 10 yards, Owen was at 4 seconds. At 20 yards, he was at 6 seconds. 30 yards, he was at 8 seconds. We have a car going by here. 40 yards, he was 11 seconds, and 50 yards, he was at 13. Okay, Izzy's order pairs are 10, 5, 28, 30, 12, 40, 15, and 50, 19. So what we have, any set of order pairs is a relation, and then sometimes those relations represent functions. So what we're going to do is we're going to see if these sets of order pairs would represent functions or not. Basically, to be a function, you have to have you can't have any x values that are duplicated, okay? So in each of these cases, we basically do. Each input or x value maps onto only one y value. So that's what we're going to look at here, is we're going to look at a mapping of this data. I'm going to list the times in this circle, 4, 6, 8, 11, and 13, and I'm going to show that each distance maps onto only one time value. So this, Owen's time, does in fact represent a function because each x maps onto only one y.
Stop for a minute.
And here we have a 4-wheeler going by. No telling what you might see out here. Okay, then let's go ahead and do Izzy's circle here. Her time values are 5, 8, 12, 15, and 19. So let's look at those mappings. 10 maps onto 5 seconds, 20 yards maps onto 8 seconds, 30 onto 12, 40 to 15, and 50 to 19 seconds. So this also would represent a function. Each x value, each input, each distance maps onto only one time. Okay, we can also look at a relation or a function in terms of a graph on a coordinate plane. So I'm going to graph those points now as well. It's hard to see here. Okay, so at 10 yards, she was at 4 seconds. At 20 yards, she was at 6 seconds. At 30 yards, she was at 8. At 40, she was up at 11. 1, 2, 3, 4, 5, 6, 7, 8. I don't have enough here. 9, 10, 11. Okay, so you can see, we'll stop there. You can see that this also is a good representation of a function because there's something called a vertical line test. And what the vertical line test is it shows, looking at a graph, whether or not a set of ordered pairs is a function. If you can draw a vertical line through the points on the graph, and none of those vertical lines would go through more than one point, then what you have represents a function. You can see that that is true here. Each vertical line that I would draw on this graph only goes through one point. So yes, Owen's data definitely represents a function. Izzy's data is going to represent a function as well because all of those things are true for her as well. We know that there's only one x value for each y value. She went from 5 to 19, so we could scale this graph and show something very similar to what we did here, and it would in fact pass the vertical line test. What I want to show you now is an example that doesn't pass the vertical line test. We have a couple more cars going by. Usually not a very busy area, but I guess on a Sunday afternoon things get a little busier. Okay, so what I'm going to do now is I'm going to combine the two sets of data. One more car going by. I'm going to move over here and I'm going to list Owen and Izzy's data together so we have more ordered pairs to deal with. So Owen was 4 here and Izzy was 5, 6 and 8, 8 and 12, 11 and 15, and 13 and 19. So what I have, I'm going to list those in terms of order pairs. We have 10, 4, we have 10, 5, we have 26 and 28, we have 38 and 30, 12, we have 40, 15, and 40, 11. I know I mixed those up, but that's okay. And then I have 15, 13, and 15, 50, 19. And if I list all of those y values over here, 4, 6, 8, 15, 13, 5, 8, 12, 11, 19, and I start mapping those, you can see that 10 actually goes to more than one y value. 10 goes to 4, it also goes to 5, which I don't, yeah I did, I wrote it there. So this x value is mapping onto more than one y value. So that right there tells me that I know I'm not going to have a function with this set of ordered pairs. If I went and plotted some of those, let's go by, well, let's just make them really small. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go all the way up to our top y value, but you'll be able to see what I'm talking about here. At 10 yards, we had 2 y values, so we have 2 points to plot. We have 4, and we also have 5 at that same y value. That same x value. At 20 yards mapped onto 6 and 8, so I would have 2 arrows there. Okay, and so let's see, 1, 2, 3, 4, 5, 6 would be 1 point there, and 8 would be another, so if I go up 2 more. This time you can see, I could plot all these points, but you can clearly see that this would not pass the vertical line test, because if I draw vertical lines through this graph, those vertical lines are going to go through more than 1 point, so that would not represent a function. So basically, that's the basic idea of functions. What makes up a function and what doesn't make up a function. A relation is just a set of ordered pairs. It becomes a function if each x value only maps onto one y value. So that's pretty much it for today, and I hope you have fun with functions.